and welcome to another video on my channel. Today, you might realize it's not a calculus video today. In fact, it's closer to a trigonometry video, but we've covered this topic in the past, but I just decided to review it one more time since when we did cover that, it was a very long time ago. So I'm just going to cover a few trigonometric addition identities, do a few examples, and that should be about it, because the next video that we're going to be doing is going to involve these trigonometric identities to prove different trigonometric derivatives. But that's going to be in the next video. So for now, let's move on to this video. The first identity that we'll cover is cosine A plus minus B. Cosine A plus minus B is equal to cosine A times cosine B minus plus sine A times sine B. And if you didn't know, if there's plus minus and minus plus, that means if it's plus, the right side will be minus, and if it's the left side is minus, the right side will be plus. So if you have a plus minus and a minus plus, that means whatever happens, the two signs will be opposite, regardless of whether one is negative or positive. So it can't be cosine A plus B is equal to cosine A cosine B plus sine A sine B. It has to be cosine A plus B is equal to cosine A cosine B minus sine A sine B. The next identity that we're going to look at is the sign addition identity. Now keep in mind, I've also covered this in one of my trigonometry videos, but I just planned for this to be a quick review. So this is sine A plus minus B is equal to sine A cosine B plus minus cosine A sine B. And if you have the same thing, so plus minus and plus minus in both of the locations, that means the sign will be the same. So if it's sine A plus B, it's going to be sine A cosine B plus cosine A sine B. But if it's sine A minus B, it's going to be sine A cosine B minus cosine A sine B. Now, there is also a way to derive the sign addition identity from the cosine identity using something called cofunction relationships, which have been covered in another trigonometry video, but that is pretty basic and is normally quite niche, and in fact you can use this to prove one of the cofunction identities. In fact, one of the problems that I'll set for you out today is almost like your homework. Not really, I don't want to see it like a mandatory task, more like a challenge problem, like if you want to do it to improve your own understanding. Because it shouldn't be about assigning people work, it should really be about challenging them and really helping them learn. And here is the third and final addition identity, which is the tangent addition identity. This can be derived from both the sine and the cosine identities, and there is also a case where the identity is undefined, where the denominator is equal to 0. Thus, that would pretty much be where if we have tan A tan B, then both of these would have to be 45 degrees, and then this would have to be a minus, so it would have to be tan A plus B, and then that would be tan 90 degrees, but that would also be undefined in general. But yes, there can be cases where the identity is undefined, where the denominator is equal to 0, but for the purpose of this video, that really won't be necessary to know, as we're just going to be solving some regular basic problems, just to get you the gist of it. Now, this is a new one that I might not have covered, so just to make sure, I decided to cover it in this video. If someone has watched my previous video, please let me know down in the comments if I have had it covered. If not, I'm sorry, and here you go, here's it covered. And if I had, it's still okay. It's still good to have a review, as this will be necessary for the next video. The first example is finding the exact values of a function. So right now, the goal is to find sine of 75 degrees. What the strategy is going to be over here is that we have sine of a plus minus is equal to sine a. We can split 75 up. A can be 45 degrees and B can be 30 degrees. And since we're adding the two together, it's going to be 45 plus 30. Then this is going to be equal to sine of 45 degrees times cosine of 30 degrees plus sine 30 degrees times cosine of 45 degrees. These are the first two steps in the problem. First to identify the formula, then to plug everything in. Now it will pretty much just be simplifying. So what will happen? It will be sine of 75 degrees instead of 45 plus 30. Then this is equal to sine 45, which is the square root of 2 divided by 2, then multiplied by cosine of 30 degrees, which is equal to the square root of 3 divided by 2, plus sine of 30 degrees, which is equal to 1 by 2, multiplied by with cosine of 45 degrees, which is also the square root of 2 divided by 2. If we do some more simplification, what we will get is the square root of 6 divided by 4 plus the square root of 2 divided by 4. Then, after that, it will give us the square root of 6 plus the square root of 2 divided by 4. So, the square root of 6 plus the square root of 2. And then, all of this will be divided by 4. Now, if you do wish so, you can factor out the square root of 2. And you can get the square root of 3 plus 1 divided by 2 times the square root of 2. And this is technically the most simplified form, but it doesn't have a rational denominator. And some textbooks or quizzes or exams require you to have it in rational form. But if not, both solutions are perfectly fine. And normally, I generally like to show both solutions just to make sure you have a clear idea on how everything works. So, these last two solutions, square root of 6 plus square root of 2 over 4, is equal, which is also equal to the square root of 3 plus 1, divided by 2 times the square root of 2. Both of these solutions are all good. They work, and that's the solution to this problem. And here is the solution slide. Pretty much very similar steps, with the result being the square root of 6 plus the square root of 2 over 4. They did not include the unrationalized form. So if you had paused the video and you had done the problem yourself and you got the unrationalized form, don't worry, you can look above and it's still correct, because all you have to do is multiply the numerator and the denominator by the square root of 2 and you will get the rationalized form. The next example is about simplifying. The first thing we need to do to solve this example, which is a simplification problem, instead of finding the exact value, is figure out exactly what formula to use. Now, over here, I don't have minus plus. Hopefully, I'll add it into this software that I'm using. I think it has a bit of customization, which allows me to do it, but that's besides the point. The goal is to figure out exactly which formula to use. And since there's a plus over here, it'll be the cosine A plus B formula. In the last one, I did the general one, and then we figured it out through there. But it's pretty easy to figure out, just looking whether you have a plus and which trigonometric function you have. So cosine A plus B is equal to cosine A times cosine B minus sine A times sine B. Now, this, after we substitute the values, will become cosine times x plus 60 degrees is equal to cosine of A, which is cosine x, cosine of B, which is cosine 60 degrees, and then minus sine of A, which is x, and then sine of B, which is 60 degrees. And over here, this is the first step in the process to solving this problem. Now, the next step will be to simplify the rest, because, as you can see, cosine 60 and sine 60 are numerical values, and that will be pretty easy to simplify. So, cosine of 60 degrees is equal to 1 divided by 2. So, we have cosine x over 2 minus, then sine x. Now, sine of 60 degrees is the square root of 3 divided by 2. So, what's going to happen here is you're going to notice that both of these is divided by 2. So, what we can do is we can add them together, or really subtract them. So, this will become cosine of x minus sine times the square root of 3. And now this is all divided by 2. And that is our final answer to this problem. Now, then, if you didn't notice already, the next problem is going to be with tangent, as this problem was sine and this problem was cosine. And let's move on to the solution to this problem. Of course, this is the solution, as I already showed you, but pretty much that's just for the people who want a quick overview of the problem, who might not have as much time, or they paused the video, already solved it, and just want to skip ahead because they already know what I'm talking about. And here is the solution. Let's apply the identity. We need to substitute, and our final result gives us cosine x plus 60 degrees is equal to cosine x over 2 minus sine of x squared of 3 over 2. But they didn't simplify by adding slash subtracting, but that is all good. Sometimes a textbook will require you to keep it at separate terms, maybe, or sometimes will require it to put it together. It really just depends on what your textbook or exam says, so just watch out for that. And our final example is another simplification problem, this time using the tangent formula. The tangent formula is copied down over here, and as you can see, it's tangent A minus B because of the tangent over here and the negative sign in between. So what we have is tangent A minus tangent B because over there it's plus minus, and on the bottom we have the opposite sign because it's plus, and it's minus plus, but I don't have minus plus, so I instead opted to do this. Maybe in another video when we have minus plus, I'll figure out how to customize these custom buttons and include minus plus as a part of there. But that's besides the point for now. What we have over here is our formula, and we are ready to substitute. So this becomes tangent of x minus 40 is equal to tangent of A, so tangent of x, minus tangent of B, tangent of 45, then divided by 1 plus tangent of A, tangent of x, times tangent of 45. This is our substitution so far, and now let's continue to simplify. Right before we simplify, let's copy this down just so we have a reference point. And now we can substitute all our known values. So tangent of x minus 45 is equal to tangent of x minus tangent of 45, which is 1. Then divide by 1 plus tan x times tangent of 45, which is 1. So it just becomes tan x minus 1 over 1 plus tan x, or we can just say tan x plus 1. So everything is nicely aligned. And there is a solution to our final problem. Tan of x minus 45 is equal to tan x minus 1 over tan x plus 1. Here's the solution. What I did over here is pretty much I chose not to do that. Just when I put it over here, when I created the slide deck, I chose not to do that and just put the 1 plus tangent x, but tangent x plus 1, 1 plus tangent x, both will work. I highly doubt any textbook or exam will care which order you put that in. So before I give you the practice problems, or really instead of practice problems, really I'd say almost like challenges, if you want to do on your own and maybe look up the answers afterwards, it's a very good idea. So here are a few common mistakes and how to avoid them. The first mistake is that assuming that sine a plus b or cosine a plus b or cosine a minus b or tangent a plus b or tangent a minus b or sine a minus b, so on and so on, is equal to just the addition of both of the individual components' sine. This is incorrect. The correct identity is sine a plus b is equal to sine a cosine b plus cosine a sine b. Then, mistake 2 is the sign errors in the identities. Make sure you have to pay a lot of attention to the plus and minus signs, especially with the cosine, and also the tangent identity, especially since it has both a plus minus and a minus plus in the generalized form. And mistake number 3 is forgetting to check for undefined cases with tangent. Basically, we need to always make sure that the denominator does not turn out to be 0. So, a few prevention strategies for these mistakes is just practice, verification, and pattern recognition. Because by the time you've done a lot of these problems, you've gotten better at the skill, and you learn to recognize patterns, these will be all but non-existent. Here are a few special cases and shortcuts. Double angle formulas is special cases where A is equal to B, and in fact, in my double angle formula video, I in fact used the plus minus, the addition and subtraction formulas to make sure that these theorems were correct. Then half angle relationships are also very similar, except they are derived from double angle formulas and can also in a way be proved by the trigonometric addition identities or subtraction identities. Then special angles is when A or B is equal to 0, 90, 180, or 270. Especially 90 because those lead to the cofunction identities. Now, complementary angles are relationships between complementary angles, which can come in all shapes and formats, because if you have complementary angles, that means it will be 90 degrees as the addition. So, some pretty cool stuff can happen, like if it's tangent of 90 degrees, it'll be undefined. If it's pretty much like a lot of other stuff, like cosine of 90 degrees, it'll be 1. 0, sine of 90 degrees, it'll be 1, etc., etc. Here are a few practice problems. And the first one is finding cosine 105 using addition identities. The second one is to simplify tangent of x 45. Minus 45. I don't know why I put that there. Then, to solve this equation, sine of 2x plus 30 degrees is equal to the square root of 3 divided by 2. You could also possibly get this from guessing, figuring out which angle is the square root of 3 over 2 with the sine. But I recommend you to do it with the addition identities. It also can be far more satisfying. And prove one of the cofunction identities. Sine of x plus 90 degrees is equal to cosine of x. Thank you so much for watching this video. It really means a lot to me. I know a lot of people on YouTube say it, but it actually is genuine from a lot of the people there, including myself. We really enjoyed the fact that you guys are watching us, and hopefully you found this entertaining, instructive, informal, and also the main goal of this is for you guys to learn, to also learn by doing, but also to learn from someone who's learned all this stuff and not exactly so much like farther ahead or like a professor, because I also am a student. I'm still learning a lot of stuff. So that's really about it. Please make sure to like, subscribe, and hit that notification button if you like these videos. And please make sure to comment any suggestions or tips for the channel down below. It would really be appreciated because, of course, I always want to improve my channel for all of you guys. So thank you so much. See you in the next one, and bye-bye.